So here's another problem. I particularly want to look at this problem because there's a couple of points that are going to come out of it. One is, first of all, we're going to find one or two techniques for integrating. Integration using partial fractions, integrating by parts, integration using algebraic substitution, maybe trigonometric substitution, and there are other methods that we can use. So the first problem you're always faced with is, which method do you use to do the integral? Which is the one that's appropriate? So I know that integration by substitution is the way I'm going to go this time, and I'm going to use this particular problem to show you how I know that. First thing I would do is I'd look at that bracket, because that's more than likely wouldn't let u be. So u is going to equal 4x squared plus 3. And I know I'm going to differentiate that because I need what du by dx is. So I can rearrange to get dx. 8x, and the 3 disappears. And I've done that in my head. I've looked at that and thought, I'm going to let that equal u. What's the differential of that? It's 8x. X is still in there. I'm going to have to rearrange this for dx. So dx equals du over 8x. So when I do my substitution, I'm going to replace dx with this. And the original variable x won't have disappeared. And if the original variable doesn't disappear, integration by algebraic substitution doesn't work. So there could be a problem here. But if you look at the original problem, I'm going to be replacing dx with du over 8x here. So I'm going to have an 8x underneath. Oh, and look, this x here will cancel with that. So the x will disappear. So I've already decided, before I look at it, that this method's going to work. Making my u equal to that won't automatically get rid of x, because x is already here. But because the substitution involves dividing by 8x, they will cancel, so I know it's going to work. So the main thing is, when you're going to use this method, if you make your substitution and then you do those little, you substitute u with that and then you replace dx with this, if the original variable doesn't disappear at that point, either the method doesn't work or you've made the wrong thing used. So you need to think again. So it is going to work in this case. So I've let u equal 4x squared plus 3. I've differentiated it and then rearranged for dx, and now I can make the substitutions. So the original integral, 3x 4x squared plus 3 to the power 5 with respect to x becomes, write down what the integral becomes. Hopefully you got that. I've replaced the bracket with u, and I've replaced dx with u over 8x. At this point, x has cancelled, and that must happen. The original variable must disappear, and it has. So now we've got, I can bring again the 3 over 8 outside the integral. So I would do that, 3/8 times the integral of u to the 5 with respect to u. So now that's just the standard integral. Add 1 to the power, divide by the new power. So it equals 3/8 of u, which is 4x squared plus 3 to the power 8, divided by, to the power 6, divided by 6, plus c. Again, I've got a 6 and an 8 underneath. 6 8s are 48, so that final answer will be 3 over 48, brackets 4x squared plus 3 to the power 6, plus c. The original integral turns out to be this. let's think about that shortcut again, just to repeat. I know I'm going to let u equal this, so I differentiate it in my head. Gives me 8x. So I'm going to have 8x underneath. 8x, the x's must cancel, so that x will cancel with the x underneath. I know that, and I'm also going to have an 8 underneath. So I'd automatically actually bring the 3 over 8 outside the integral. And then I'd integrate to get the bracket to the power 6 over 6. So I'm going to have 6 times 8 is 48 underneath. So with practice, and if you're doing these routinely, you'd be able to almost make a shortcut in a similar way. With routine and use of the chain rule, you can actually use that and do it in one hit almost. So that's the answer to that particular problem.